Starting the recording now, and as is with all these webinars, I do need to announce the webinar disclaimer. This WebEx service includes a feature that allows audio and any documents and other materials exchanged or viewed during this session to be recorded. By joining this session, you automatically consent to such recordings. If you do not consent to the recording, please do not join or participate in the session. This WebEx service is intended to supplement the classroom experience. Duplication or redistribution of lecture capture recordings is prohibited without appropriate consent. All right, what I want to talk about is essentially Chapter 3. And before I do that, I spent a good part of today grading everyone's labs for lab number 2. And I thought I'd just go over some of the feedback that I'd like to give you on what I found that I saw consistent people doing that needs to be corrected. Number 1, make sure you have the correct file names. I'm not seeing this abused too frequently, but I do see incorrect file names. If I ask you to call your project Lab 1, I don't want it to be called Restaurant Bill. I want it to be called Lab 1. All right, so please keep that integrity there. Please use proper naming conventions. I even specifically said in the lab, please call the variables these names, and people chose to choose their own names. I have a reason for why I want to do this. Oftentimes you're working on a big project with many other people, and they rely upon the variable names that you have been told to use so that they can use similar or corresponding or sticking to the same convention in their programs, so that when you integrate, as we discussed, I guess last week, in integration testing, it's easier to test when you have like a consistent set of variable names. So if I ask for something in a lab, I'm really going to be sticking to seeing that you guys do it. And obviously, if you don't, I'm going to take some points off. Appropriate indentations. I'm still seeing indentations kind of floating all over the place. I really want you to spend the time to indent your code according to the conventions that we talked about in the earlier chapter. I'm still getting just Java source code. And I'm going to start losing my patience on this because this really slows me down. You need to send the entire NetBeans package zipped, not just the source file. I can't do anything with the source file. I need all the other pieces. It's like sending me the engine to your car and saying, how does it run? I can't determine that until I put it in the car and give it a test drive. So please send me the entire NetBeans package zipped. Number 6, oh no, it's number 5, documentation, header block, and commenting. Please do use appropriate commenting. Some of you are still not putting a documentation header block in there. I'm going to start taking more points off. It is critical that you do that. It helps me to know who I'm correcting as I'm grading these, as I'm juggling all these other different things, and it's also going to be used in your future for any programs that you write for any business that hires you. Number 6, very, very important. Please focus on the assignment details. I take great pains to write these assignments up, whether they're in class or whether they're labs. In class is intended to give you a warm-up for the lab. I'm not grading the in-class or the pre-lab if you're an online guy, but I do want you to follow my instructions. I will take points off in the lab if you do not follow my instructions specifically. You can't cut corners, you can't abbreviate, you can't change the variable names if I specifically ask for that. I'm going to pretend like I'm the customer. And if you go ahead and not give the customer what the customer is asking for, you won't be a customer for that customer for very long. So I'm kind of prepping you for that. Please focus in on the assignment details. Focus on thorough testing. In the case of the restaurant bill, I did not see many people testing their final bill. Now, I don't know if you ever went to a restaurant, but if a customer walked out and the bill didn't add up right, or the tip recommendations weren't calculated correctly, you might have a problem going back to that restaurant. So the manager might have a problem with hiring you to write their restaurant bills. So please understand that you need to thoroughly test your code before you submit it. I am still getting some submissions that don't compile. And I'll tell you right now, if an assignment is submitted and it doesn't compile, it's going to be -20 right off of the bat. You're going to start with an 80. And if I feel like correcting it after that, it's just going to keep going down and down. Because it's very hard for me, especially as the assignments get more and more challenging, to figure out whether or not you actually thoroughly tested this code and whether or not it actually works. And then last but not least is number 8. Many of you are still submitting your assignments right near the deadline. And I'm just saying you're flirting with disaster by doing that. So please do not put these assignments off, certainly not the labs. Okay, having said that, I hope my voice can get through this. I've been coughing and flat on my back for the past 4 days now, so I hope it gets through this session. All right, the motivations for this Chapter 3. If you're assigned a negative value for a radius in listing 2.2, compute area with console input.java, well, everybody knows that a negative radius doesn't exist. The program would print an invalid result. The area would be something that would be negative. If the radius is negative, you don't want the program to compute the area. How can you deal with this situation? In a real-life situation, if you have bad data coming in, we're only working with one program or one iteration of data. But imagine if you were processing 100,000 records coming in, and it was a bad file, and it took an hour to process, and it was a bad file, and you processed that for a full hour, and all you were doing was processing garbage. You've just wasted an hour. So what you want to do is you want to test right up front, are you getting bad data? And if you're getting bad data, then you need to act upon it immediately, so you don't waste an unnecessary hour of processing time on data that's not going to be used, on the results of the data processed. It's not going to be used. So how do you deal with this? First thing we're going to talk about is the Boolean type and the Boolean operators. Okay, Mike, you got a question? Take yourself off mute. It's Michael K. Michael K., do you have a question?
Yeah. Within my question about thinking about the assignment, I'm explaining about the calculation, even though I thought the integer sometimes, you mentioned estimates the numbers it could have been like rounding to the nearest number, but I thought trying to make it, I don't know how many digits that it has to be, but when I tried to do that, it kept, it didn't show the exact number of prices. And why did you tell me?
All right, Michael, this is Michael Shiro. Michael K is the one that raised his hand.
Oh, my apologies. I didn't know. I thought you mentioned me. Okay.
Michael Shiro, please. Michael, we're gonna take that offline, okay? If you have any questions regarding your specific lab submissions, we'll take that offline. You can send me a Blackboard message, okay?
My apologies. Thank you.
Okay, Michael K., did you have a question? Okay, I guess he pulled his hand down. All right, so we're talking about the Boolean operators and the Boolean type. There was a guy, George Boole, back in, I think he lived in the 1800s, and he's kind of like the father of this whole notion of binary computing. And often in a program, you need to compare two values, such as whether I is greater than J. Java provides 6 comparison operators, also known as relational operators, that can be used to compare two values. The result of the comparison is a Boolean value, and a Boolean value can be true or false. It's basically a binary notion. This is a statement. It's a Java statement right here, and it says we're going to declare a variable called b. It's going to be of the type Boolean. Now, we've declared variables before of the type int and type double, type char, type short, byte. Now we're going to introduce the type Boolean. And this variable b is going to be assigned the results of this expression. This expression is 1 greater than 2. Well, when you think about that, 1 greater than 2 is false. That is not true, so it's false. So the value for b would be false. A Boolean can only be true or false. In this particular statement, the value for b would be false because of the resulting evaluation of this expression. Here we have the relational operators. We have a Java operator, the less than sign. The mathematical symbol is the less than sign. And here's an example, radius less than 5. I'm sorry, radius is less than 0. And the result is false. Less than or equal. In mathematics, they put the little line underneath it. And the way you would write that in Java is the radius less than or equal to 0. And hopefully the result of that would be false. The next Java operator is the greater than sign. It's the same as in mathematics. It looks like that. And the radius greater than 0, hopefully it will be true. In Java, we write greater than or equal to this way. In mathematics, you write it this way. And this is what the expression would look like, which would yield a true. This is the equivalency operator. It's a double equal sign. In math, it's the equal sign. It means equal to. And what we're saying here is the radius equivalent to 0. This is not an assignment statement. This is an equivalency operator. And we're saying, is the radius equivalent to 0? And hopefully it'll be false, because that wouldn't be a circle. And then the not equals in Java is written like this, the exclamation point followed by the equal sign. And in mathematics, it's the equal sign with the slash through it. If you would say the radius is not equal to 0, well, if that's the case, then it's true. We're not taking care of the fact that if the radius was less than 0, but in this case, we'd just be looking to see if the radius is not equal to 0. So those are your Java operators. Those are your relation operators written in Java. Let's take a look at this simple little addition quiz. This example creates a program to let a first grader practice addition. The program randomly generates 2 single-digit integers, we'll call it number 1 and number 2, and displays a question such as, what is 7 plus 9 to the student? After the student types the answer, the program displays a message to indicate whether an answer is true or false. I've got it queued up right here. So here is, let's make it a little bit larger so we can see it. Here is our addition quiz program. And the first thing we're going to do is generate 2 random integers, number 1 and number 2. We're going to use the current time millis method in the system class, and we're going to do a modulus 10, and then we're going to do a integer division 7, modulus 10, just to give it a little bit of a twist, but they're basically doing the same technique, and you're going to get 2 different random integers between 0 and 9. The next thing you're going to do is you're going to create a scanner object. It will be called input. And we're going to ask for 2 numbers. What is whatever the first random number is, plus whatever the second random number is. And then we're going to get, using the next int method in the scanner object, input, and we're going to assign the student's answer into the variable called answer of type int. And then we're going to print out the results. Whatever the number is, plus whatever the second number is, equals answer is, and here's where we have the expression where it will get evaluated to be either true or false. And it gets evaluated because of this equivalency operator. Is the answer equal to number 1 plus number 2? If it is, this overall result will be replaced with true. Otherwise, it will be replaced with false. Let's play the game. All right, the first question is, what is 0 plus 4? I'll say 4, hit enter, and here's where this came back out and said 0 plus 4 is true. 0 plus 4 equals 4 is true. So this gets evaluated to true. I'll do it one more time incorrectly. 6 plus 6 equals 11. And this will get evaluated to be 6 plus 6 equals 11 is false, because 6 plus 6 equal to 11 is false, and that's what gets displayed. Okay, one-way if statements. Boolean expressions are what get put inside, are what get put inside an if statement. So you see this parentheses here, and inside the parentheses there is a Boolean expression that's going to evaluate to either true or false. And depending upon whether or not it is true, if it is true, the code inside this curly brace and this curly brace will get executed. If the Boolean expression is false, then it's going to skip over this block of code and execute the next instruction or next block of code. Here is the flow chart for this. The diamond shape is a select statement or an if statement. And hold on just one second. Oh, okay. Yeah, I'm on a webinar right now. Maybe a couple hours. Yeah. I'm talking right now. Yeah. Right. Okay, back to the flow chart. So this diamond shape is a decision block or an if statement. So this basically represents a Boolean expression for an if clause. And if the clause inside this parentheses is true, you take the true branch. Otherwise, you would take the false branch. Here's an example in Java code. If radius is greater than or equal to 0, well, this is going to be evaluated to be equal to 0. It's greater than or equal to be 0. If it's true, then we're going to execute from here down to here. And that will avoid us calculating the area of circles that have negative radii. So this will only execute from here down through here if this radius is greater than or equal to 0. And we're going to calculate the area is equal to pi r squared and print it out. Okay, this is wrong. This is correct. You need to put parentheses. Don't forget the parentheses like this, because it will not process. If you have questions, was that Julio? Do you have a question, or because I'm seeing things pop up, and if you have a question, I would prefer you just kind of coming off a mute and just piping right in, because it slows me down if I have to read things. Julio, did you
I was responding to, I think it was Drake who posted a question.
Okay, all right, okay. If you have a question, sometimes you can respond directly to that person, and then I think I don't see it. But anyway, the point behind this slide is basically make sure you put parentheses here. This right here is the equivalent of that. What this is saying is that if I is greater than 0 and you have a block and there's only one statement inside the block, you don't need the curly braces. So they've removed the curly braces and said if I is greater than 0, well then execute the next sequential instruction. Otherwise, skip over the next sequential instruction and go to the one after that. So if I is greater than 0, we're going to go ahead and say I is positive. If I happen to be negative 12, if negative 12 is greater than 0, it's false. It's going to skip over system.out.println and it's going to go to the next instruction. You do not need those curly braces when you have just one statement for the truth branch. Okay, how about a simple if demo? Write a program that prompts the user to enter an integer. If the number is a multiple of 5, print high 5. If the number is divisible by 2, print high even. All right, so here's the code. I'll run it. It says enter an integer. 4. 4s, it's high even. Okay. Let's run it again. And I'll do 20. It came back and said high 5 and high even because it is a multiple of 5 and it's also even. So how's this working? Well, we're getting an integer from the console. We're putting it into the variable number. And then we're doing a modulus 5 on number and asking, is it equivalent to 0? Don't forget when you're writing your code to put double equal signs. I know it's a tendency for everyone to forget that, but you need to make sure that you put in double equal signs. This is the equivalency operator. It will yield a true and false. If you do not put a double equal sign, it's going to be an assignment operator. And it's going to take whatever's on the right-hand side and assign it into what's in the left-hand side. And then it's going to evaluate to see whether or not it's true or not. It's going to be unpredictable. So you don't want to omit that second equal sign. So number, what did I use? I used 20. Okay, 20 modulus 5 equivalent to 0? Yes, because there is no remainder when you divide 20 by 5. So it's going to print out high 5. That's for that if statement. Now we're going to execute the next if statement. If 20 modulus 2 is equivalent to 0, it is because there's no remainder. We're printing out high even. So here's some simple examples of a simple if statement. A two-way if statement. If, for example, you have a Boolean expression and it's true, you execute these statements if they're true inside the block. A two-way statement would have an else clause to it, and after the else, you can go ahead and put curly brace, and if this particular Boolean expression is false, it will not execute what's inside this true block, but it will execute what's inside the else block or the false block. And likewise, if you only have one statement in your else, you don't need the curly braces. Here's the flow chart. You have a Boolean expression. If it's true, execute the statements that are to be processed when true. When it's false, execute the false ones. Okay, here's an example. If radius is greater than or equal to 0, right here, we have this curly brace going all the way down to this curly brace. And this looks like it's going to go ahead and compute the area of a legitimate circle that has a radius greater than or equal to 0. And print it out. Else, now we're going to go ahead and print negative input. So you're not going to waste your time processing all this. You're just going to print out negative input. And you really don't need these curly braces because you only have one statement in here. So you could just eliminate this curly brace and that curly brace, and everything would process identically. Multiple alternatives of if statements. Here's one way you can go ahead and determine how to determine a letter grade based upon a numeric grade. Here we have if a score, some variable, let's say score is of the type double, and you want to know if score is greater than or equal to 90.0, well, if the score is 99, then it'll take the true, which is the next sequential instruction, and print out the person got an A. Else, it would do nothing. So we would drop through this. But let's say the person got an 89. Ask the question if the score is greater than or equal to 90. That's false, so we're not going to do this. The person got an 89. Now we do the else, and we're going to add another if to this. Else, you can ask, is the score 89 greater than or equal to 80? Well, it is. 89 is greater than or equal to 80. So we'll print out B and then fall through because the other else's don't apply. Likewise, 79. It's not greater than 90. It's not greater than 80. It's greater than 70, so you print out C. You continue on all the way down, and you can derive letter grades based upon using if, else, if, else, if, else, all the way down to the F, where you just conclude if the score is greater than or equal to 60, and it's not, well, then you got something that's below 60. This is better than indenting and having a staircase type look. This makes things a little bit cleaner to follow. So that's the recommendation that the book tells you to use. Here's the same, whoops, let's go back. Here's the same thing in a flow chart. I'm not going to go through it again, but you got the idea. But this is how you would ask the questions using all these decision blocks. Here's your true branches, and here's your false branches. Eventually, it becomes an F. First one is an A. I already went through this, so I'm not going to go through that. Okay, the else clause matches the most recent if clause in the same block. Okay, be very careful of that because it doesn't have, you got to be careful with your indenting. This else here matches this if. Even though you lined it up under this if, it's really going to be aligned and associated with this if, not that if. That's why this is better, to make sure your indenting is appropriate when you start using if and else's, and especially these nested ifs, when you have an if within an if. All right, let's see if we can follow this thing here. Nothing is printed from the preceding statement. To force the else clause to match the first if clause, you must add a pair of braces. All right, we got I is 1, J is 2, K is 3. I, J, K, 1, 2, 3. All right, if I, which is 1, is greater than J, that's false. So we don't go here. We need to make sure we put our braces in, and we will do the else, and then we will quickly see that we're going to print out B. The statement prints out B. Very important that you put your braces in the right spots. Adding a semicolon at the end of an if clause is a common mistake. Don't do this. This essentially basically just wipes out the if clause, and everything else is nothing more than a statement that will get executed. So here's a tiny little mistake. You're going to get into the habit as you write more and more Java code to just through habit, you're going to go ahead and hit that semicolon key. That's why the same line is where the curly braces have become the tradition, to avoid that. This mistake is hard to find because it's not a compilation error or a runtime error. It is a logic error. This error often occurs when you use the next line block style, which is why pretty much the industry has gotten away from this and opted to have it on the same line. Okay, here's a tricky little thing here. If number modulus 2 is equivalent to 0, well, then we're going to assign the value true into the variable even. And even, presumably, is a variable of the type Boolean. Else, even is going to be assigned false. This statement, this series of statements, is the same as this thing here, where we're declaring even as a Boolean, and we are doing this expression. Number modulus 2 equivalent to 0. I don't know what number is, but let's say it's 4. 4 modulus 2 equivalent to 0. If that is true, in fact, 0, which is true, then even will get the value true. You can use either approach. You can say if even is equivalent to true and print out it is even, or you can just put in parentheses even. This will get evaluated to true or false. So you don't have to go ahead and use the equivalency operator when you're working with Booleans. You can just put in parentheses the Boolean, and it will evaluate itself to be either true or false. If it's true, it executes the next sequential instruction. All right, this example creates a program to teach a first grader how to learn subtractions. The program randomly generates 2 single-digit integers, number 1 and 2, and with number 1 greater than or equal to number 2, and displays a question such as what is 9 minus 2 to the student. After the student types in the answer, the program displays whether the answer is correct. Let's look at subtraction quiz. Okay, notice these programs are not very long. There's a lot of I put a lot of comments in here, so if I took all the comments out, it would be very, very short. But they can get very complicated. As we start working with ifs and Boolean logic and nested ifs and some of these relational operators, it can get very, very confusing. So let's go through it kind of carefully. It's also a good idea to put comments in. I use line comments here because it's not always apparent what you're driving at when you are writing code, especially using Boolean operators. Well, this one is obvious. We're generating two random integers between 0 and 9. In this case, we're using the random method from the math class. And just to focus in on that, what the random method does is it returns back the fractional second from the system clock. So whatever that fractional second is, it will get multiplied times 10. So for instance, if it returns back the fractional second 0.1, 2, 3, 4, 5, 6, 7, 8, 9, well, when you multiply 0.1, 2, 3, 4, 5, 6, 7, 8, 9, and you multiply it times 10, it's now going to be 1.2, 3, 4, 5, 6, 7, 8, 9, etc. So that now gets casted, that 1.23 gets casted to an int, and now we're just going to have 1. And then 1 gets assigned into the number 1. We do it again for number 2. However, now it goes to the system clock a nanosecond later, and it gets the system clock, and it returns back the fractional second from the system clock using the random method from the math class. And let's say that is 0.234567891, or 0.23456789565, whatever, keeps on going. And then you multiply it times 10. Well, that's going to be equal to 2.3456, etc. When you cast it to an integer, it takes the integer piece, which is 2, and assigns that into number 2. So we've basically taken two random integers using the system clock to generate a number between 0 and 9. You can also use the current time in milliseconds method, which we used earlier, but this is a new way to do it, so we're going to use it that way. All right, the second step. If number 1 is less than number 2, we need to swap them. After all, if I said to this, first grader? If I said, what is 1 minus 2? The first grader is going to get completely confused. So we need to make sure the first number is the bigger number. We can use an if statement. We can use a selection statement. If number 1 is less than number 2, well, then we're going to go ahead and flip them, right? What we do, we want to make sure that number 1 is greater than number 2. And the way to do that is to create a temporary variable to hold number 1. So we create a temporary variable that's a hold variable, and we move number 1 into the temporary variable. Then we take number 2 and move it into number 1. And then once 2 is in number 1, then we can take what's in the temporary variable, which was the old number 1, and then we put that into number 2. And that essentially flip-flops the numbers. So now we have number 1 being larger than number 2. Now the first grader is not going to get confused. Third step, print out what is number, whatever it is. Let's print this here. Let's run this. All right, so it generated 6 and 1. It put 6 as the first one, and 1 as number 2. This is number 1 is 6, and number 2 is 1. And it says, what is 6 minus 1? And now we get from the first grader using the next int method from the scanner class. And we're going to go ahead and assign that into the variable called answer. And now we're going to use that technique that we just went over and say, if this expression right here, number 1 minus number 2, that's 6 minus 1, is equivalent to the answer that we got from the first grader, well, then we're going to say you are correct. If not, then we're going to go ahead and say, this is one statement, so we don't need curly braces. We're going to say you are wrong and give them the correct answer. So I'm in the middle of something here. So 6 minus 1, I'll say 3 in error, and it doesn't execute this because this is false. So it hops over this instruction, and it goes to the next sequential instruction, which is right here, and it prints out your answer is wrong. 6 minus 1 should be 5. Everyone, I hope, understands how that whole thing works. It's a good example of using Booleans and if statements, selection statements. I'm going to skip over this body mass index thing, but I think everybody understands how that thing is. And basically, everybody's got a body mass index, and it's calculated by, I guess, your height and your weight and a bunch of other factors. And then if your BMI is less than 18, you're underweight. If it's 18 to 25, you're normal. Excuse me. 25 to 30 is overweight, and less than 30. If the BMI is greater than 30, then you're obese. I'll have you take a look at that because that's just too lengthy to go through on a webinar. As is this tax thing. I'm not going to go through that either. All right, logical operators. We have here the logical operator, the exclamation point. In Java, that is the not sign. Its descriptions, they say, is logical negation, but it basically takes the opposite Boolean value of what exists. This is the AND operator, the double ampersand. This is the logical OR operator, the double bar. And here is the exclusive OR. It's an upward caret. And we're going to go through some examples of how to use these things. Here's a truth table for the NOT operator. Let's say we have a Boolean variable called P, and we assign it a value of true. Well, if we go ahead and put a not sign in front of that P, that now becomes false. And likewise, if we have P set to false, and we put a not sign in front of that, it will then flip it to its opposite and make it true. Here are two examples. Age greater than or equal to, greater than 18, the not sign, if, let's see. Oh, example, okay, here we go. Example, assume age equals 24 and weight equals 140. So let's evaluate this. We'll go with inside the parentheses first, and we're going to say age greater than 18. That is true. Age is 24. But we're going to take the opposite of that, the not of that, and we're going to make that true become a false. And there's your explanation. It's false because age is greater than 18 is true, and we made it the opposite. Is the weight equivalent to 150? Well, that's false. The weight is 140. We take the opposite of that, or the negation of that, or the not operator, and then that now becomes true. Because weight is equivalent to 150 is false. We'll now make that true. That's two examples of how you could use the not operator in a Boolean expression. Truth table for operator and the ampersand, the double ampersand. That's the AND operator. We have two variables, P1 and P2. P1 is false, P2 is false. When we AND those two together, the overall results will be false. If we have P1 and P2, where they're false and true, when you AND them together, they will both be false. Likewise, if you have true and a false, the overall result will be false. The only time that you can have an overall resulting true is in an AND operator is when you have both operands, both P1 and P2, equal to true. So P1 ANDed with P2, a true ANDed with a true is going to be an overall true. They both have to be true in order for the overall result to be true using an AND operator. And here are some examples. I'm not going to go through all of them. Here's an OR operator. We have the same thing. We have the same scenarios. False, 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 true, false, false, true, true, false, and true, true. If you have P1 ORed with P2, a false or a false is going to be an overall false. A false or a true will be a true. All you need is one true for the overall result to be true in an OR operator. So we have one true here, so the overall result will be true. A true ORed with a false will be an overall true because we have one true here. And obviously two trues, a true ORed with a true, well, that's obviously going to be a true. And here are some examples you can look at. Okay, we have the exclusive OR. Here we have same situation, same scenarios. False, 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 true, true, false, true, true. P exclusive ORed with P1 exclusive ORed with P2 basically follows the same logic as the OR, except when they're both true, then it becomes false. So let's just step through this. A false exclusive ORed with a false is an overall false. There is no true to any of this. A false exclusive ORed with a true would be a true, because you have a true. You have just one. A true exclusive ORed with a false would be an overall true, because you have this true here. A true exclusive ORed with another true, you would think would be a true. In a regular OR, it would be, but in an exclusive OR, when you have two trues together, the overall result becomes a false. Excuse me, just one second. Okay, I'm back. I'm hoping nobody heard. Did anybody hear me coughing my head off? Okay, I guess you didn't. I'm going to use this mute button pretty quickly and have it on the trigger here. Okay, so that's the exclusive OR. It's a little tricky, and there are times when in programming you can use this exclusive OR. You will, however, find those other operators, logical operators, the AND the NOT, and the OR used far more extensively. Let's look at a program, test Boolean operators. Okay, a nice short, sweet program. And we're going to get scanner input. And we're going to go ahead and ask for an integer. And the Console operator will enter a number, an integer of some sort. First thing that happens here is we're going to take that number, whatever it may be, and do a modulus 2 on it and set it and say, is it equivalent to 0? And is the number modulus 3 equivalent to 0? So we've got some combinations going on here now with these Boolean operations. It's probably good to use some example data to follow it easier. I'll enter an integer. Let's say, what's a good one? How about 12? Okay, enter an integer. I put 12. 12 is divisible by 2 and 3. 12 is divisible by 2 or 3. I entered 12, so 12 modulus 2 equivalent to 0. That's true. This is an overall true right here. It's going to be ANDed with another Boolean expression. The left half is true. What about the right half? 12 modulus 3 equal to 0. Yes, 12 modulus 3 is equal to 0. So we have a true on the left-hand side and a true on the right-hand side. A true ANDed with a true is an overall true. Therefore, the program will execute the next sequential instruction. Next, 12 modulus 2 equivalent to 0? Yes, it is. It's true. I have that ORed with this piece, 12 modulus 3 equivalent to 0. That's also true. So I have a true or ORed with a true, and that will also yield an overall true. So this expression, this statement will get executed as a result of that expression, the Boolean, the large composite Boolean expression. And now we're going to print out the number is divisible by 2 or 3, which came out down here. The last one here, if number, which is 12, modulus 2 is equivalent to 0, okay, that's true, correct? 12 modulus 2 is equivalent to 0. I'm exclusive ORing that now with the second half of this expression inside the parentheses. And I'm saying is number modulus 3 equivalent to 0. That is true as well. So I've got a true on the left-hand side, exclusive ORed with a true on the right-hand side. True exclusive ORed with a true is going to be a false. So therefore, this statement here does not get executed. This one right there. It will skip over that statement and go to the next sequential instruction, which happens to be the end of our program, and the program ended as was expected after this statement. Okay, so here are some examples of where you can use these operators, including an exclusive OR, in combination. All right, let's try test Boolean operators. Okay, what do we got going here? We're getting scanner input. We're asking for an integer. We're going to put it into number, and then we're going to do the same. We just did this. We just did this. I guess I'm losing it here. 12. Yeah. All right. Moving right along. Oh, okay. I see. Okay. There's two slides with the same program on it. Okay. All right. Skipping along here. We're going to skip over. These are the bitwise We don't need to spend much time on that. But here's an interesting little application of some Boolean logic here. This program determines leap year. Now, we think we know what leap year is. Leap year is, every fourth year, right? Well, it's not quite as simple as that. It's not every year that's divisible by 4. It's actually a little bit more complicated algorithm. This program first prompts the user to enter a year as an int value and checks if it is leap year. And it uses this very simple algorithm. A year is a leap year if it is divisible by 4, but not by 100, or it is divisible by 400. Okay, now how do you translate that over into code? Well, you need Boolean operators. And what we have here is a very long expression right here, okay, which will get evaluated to true or false, ORed with this expression right there. So all we need is this left side to be true, or this right side to be true. And if either are true, we have a Boolean. We have a leap year. And we can run the program just to show you how it works. No, I didn't open that. Okay. What's it called? Leap year? Yeah, leap year. Okay, here it is. It's going to ask for the year, and it's going to use this big Boolean. We're going to get the year from the console, store it into the variable called year, and then we're going to go ahead and just declare a variable of the type Boolean. It's going to be called is leap year. You'll often see variables called is something or other, is leap year, is Tuesday, is springtime, and when you see that preceding is, that kind of indicates that this variable is a Boolean. It's going to have a value of only true or false. So this expression here is going to get evaluated, and it will get assigned into the variable is leap year. And that expression came directly from the PowerPoint. So we can pick any particular year. 2016 is a leap year. It is true. And all we do is we print it out and say 2016 is a leap year, and then we put the Boolean expression concatenated at the end of our system.out.println line, and we'll get true at the end. It gets a little tricky when you got like 2000. 2000 is a leap year. 2100 is not a leap year because of this Boolean expression on this side. So you can see how that works. So there's a real simple program that can solve a very complicated problem for people. Skipping over the lottery takes too long. Switch statements are pretty important. I'd like to go to an example of a switch statement. And I'll use the Chinese zodiac as an example. Okay, very simple program. It's essentially just using a switch statement. A switch statement comes in very handy when you have what look to be a series of ifs. And a better way to code a series of ifs so that it's easier to comprehend for not only yourself, but the next person that comes in and has to maintain your code would be to use a switch statement. And I would read up on it in the book. It's got some conditions that it has to adhere to, but essentially here's what we're going to use it for. We're asking for a year, and we'll put in a year, and we'll put it into the variable year. And then, using the switch statement on year, modulus 12, okay, so in other words, it's going to be whatever the year is, it's going to have, let's just run this. We'll do 2016 is the year of the monkey, according to the Chinese zodiac. And the way that works is it's using the modulus function to return the remainder. It's going to divide 2016 by 12, throw away the quotient, and return back the remainder. And evidently, the remainder was 0 for 2016. This must be divisible by 12. So as a result, it says the case is 0. So this will be a 0. This overall result in here will be 0. And it will execute this case and print out monkey. So it's the year of the monkey. The thing I want to stress is this important break statement. If you do not put this break statement in after where it hits the case that the condition exists upon, if you do not put this break statement in, it will step through each one of these cases and execute them. So you need to make sure you put a break statement in order to get out of this switch statement and continue on to the next sequential instruction. So that's a very easy way to go code something that without a switch statement, you'd have to use a series of ifs, which can get very complex, especially when you're using elses and else ifs and these other things. I'm going to skip over conditional operators and operator precedents. Applying operator precedents and associativity rule, the expression, we all know what the orders of operations are. It's PEMDAS, right? Parentheses, exponentiation, multiplication, division, addition, and subtraction. That's an oversimplified perspective. There's actually a lot more operators beyond just those handful represented in PEMDAS. And you can look at the appendix in the back of the book or look it up on Google it, and you can see that there are different levels of precedence. And a higher precedence will mandate that that get done before a lower precedence. So for instance, we know that multiplication and division have the same higher level of precedence as opposed to addition and subtraction. And we know parentheses is done at the highest level. So let's take a look at this big, long expression here in Java and understand how the actual computer will compute. The first thing that this will do in this expression is it will do the parentheses first. We have a plus sign, a multiplication greater than multiplication, parentheses, plus, and a minus. So we're going to do parentheses first and combine 4 plus 3 and make it 7. Now we have 7 down here. Now we got a plus, a multiplication, a greater than sign, a multiplication, and a minus sign. Well, multiplication gets next. So we're going to do 4 times 4. There are 2 multiplications, one here and one here. It will go from left to right. So we have this multiplication and this multiplication. The computer will do this one first and come up with 16. Now we have 3 plus 16 greater than 5 times 7 minus 1. Well, we got a plus, a greater than, a multiplication, that's the highest order so far, and the minus. So we're going to do this next and come up with 35. And now we have a plus, a greater than, and a minus sign. What gets executed next is the plus, because it is the same level of precedence as the minus. When that's the case, it goes left to right. So we'll do the left one first, and it will combine 3 and 16, get 19. We have a greater than sign, and 35 minus 1. Well, a minus sign gets done next, so we got 34. And now we have 19 greater than 34. This is going to get evaluated, and we're going to say is 19 greater than 34. This overall expression, the result will become false. So that's exactly how the computer does these rather complex, convoluted Boolean expressions using multiple operators of different types.
Can I ask a quick question?
Sure, go ahead.
The example, 2 lines up, 3 plus 16 and 35 minus 1, had the signs been switched and the subtraction sign been in front and addition in the back, it still would have read left to right and did the subtraction before the addition?
Yes.
Okay.
They're identical in the level. Okay, and there's a chart. There's a chart you can take a look at, and they actually quantify the level of precedence with a number. And the number that's quantified for addition is the same number as subtraction. And
gotcha.
Likewise,
so it's not exactly like PEMDAS.
It's not exactly like PEMDAS, right? And people oftentimes literally use PEMDAS and say, oh, well, does that mean multiplication is always before division because M comes before D? No, that's not true. The computer, the way it computes, is going to go with these levels of precedence and associativity rules.
Beautiful. Thank you.
Okay, good. Good question. All right, good. I think I'm not going to talk too much about debugging. Hopefully you're getting a full exposure into debugging. The code that we're starting to write now is getting a little bit more challenging, and I'm sure you're getting all these different types of bugs and errors and logic errors and compile errors and things like that, and you're getting comfortable with NetBeans. And you can always put in a system.out.println, open paren, and put the variable name in and see what's inside the variable and see what you're getting, and then do it step by step by step. And if you have a big, long expression, comment it out and just do one piece of the expression and print it out. Then add a second piece and print it out, and add a third piece. And maybe the third piece is where you're making your error. So now it's a process of elimination. You're basically ruling out things to zero in on where you find the error. But debugging is a bit of an art, and it takes time. And there are tools in NetBeans. I'm not going to go through them, certainly not on a webinar, but you can go explore up in the toolbar up at the top, and there are debugging tools where you can actually set breakpoints and stop the processing and see what the contents of all the variables are at any particular point during the processing of your program. Okay, that brings me to the end of Chapter 3. I want to go over your lab because it's a little bit more challenging. And definitely do not wait until the end. This is what, Thursday? So don't wait until Monday at 11 o'clock at night to try and tackle this one. You'll frustrate yourself pretty quickly. Again, this is one that you may want to take in pieces. I called it sorting 3 odd and even integers. I want you to use decision statements, which are if statements, and logical operators only. I put that in big, bold, black, underlined letters because oftentimes students will go ahead and apply Chapter 8 to solve Chapter 3's problems. And I'm not going to permit that. I'm not going to give you credit for that. You have the tools at your disposal up through Chapter 3 to solve this problem. I want you to build the fundamentals, the logical fundamentals in your brain to solve these problems. Later on, we can find out ways in which to use loops and arrays and other methods that are already built for us, formatting methods, things like that. But for right now, if we have not discussed it, and it has not been brought up in the chapters that we've discussed, I do not want you to use them. So this assignment is going to be using decision statements and logical operators only. Create a Java application in NetBeans called Lab 3 that asks the end user, please enter an integer between 0 and 99. And next, enter another integer between 0 and 99. All right, so the user is going to enter two integers. Let's say 20 and 40. The program will reject any entries that are less than 0 and greater than 99. All right, sounds like an if statement. If the entry is less than 0 or the entry is less than or greater than 99, then print out a message. So those are some if and ors. If there are two incorrect entries per entry request, the program will end using the return statement. So if you get two in a row, obviously the end user is not reading, and you can just end the program. And the way you can end the program right then and there is just to type in return with a semicolon, and it ends the program.
I have a question, Professor.
Yes, go ahead. Yes, go ahead.
In the book, there is an example of one of the programs that uses the system exit method in Chapter 3.
Yep.
Is it the same thing to use that, or should we use the return statement, particularly in this case?
Great question, Julio. I try to expose you guys to as much as I possibly can with regards to programming. So yes, the book uses a system.exit with a return code 0. Now I want to introduce to you just a straight return. And the difference is, sometimes what happens is when you return control from your program back to the operating system, oftentimes the operating system wants to know, how did that program end? Did it end happily or did it end miserably? And you can go ahead and put exit with a return code 0, 1, 2, 3, and then those numbers that get passed back to the system, back to the operating system, they can be interpreted as, is this a severe crash of the program that just had control, or is this a slow, is this a return back that's not a problem at all? So that's the difference basically between the two. A return, so just a straight return, would not give the operating system any indication as to the reason why it returned. Okay?
Okay, got it. Yep, thanks.
Okay. Okay, so if you get two in a row, you issue the return statement. The program will then generate 3 random integers within that range. What range did I say? I think I put in 20 and 40. So I want you to generate 3 random integers between 20 and 40, whatever the 2 integers then that I put in it between that range. You can do that using the following formula. I gave you the formula. This is actually pretty neat. You can generate an integer, a random integer, if you go ahead and code whatever the min is. So in my case, it would be 20, plus we're going to cast to an integer. We're going to use the math.random method with nothing inside, times open paren, max minus min, that's 40 minus 20, plus 1, close paren, semicolon. That whole thing will generate a random integer between 20 and 40. You can do that for integer 1, integer 2, and integer 3. I'm asking you to generate 3 random integers. So to do 1, use this. You could call it integer 1. Do it again for integer 2, and then do it a third time for integer 3. Same exact code. All right here. The program will then sort them. So I don't know, let's say we picked, 25, 30, and 32. I'll probably never remember those. Okay, the program will then sort them in ascending order. So what did I say? 20, 30, and 32. So it's already in ascending order. But if they didn't come in, then it would get sorted into ascending order. You need to use decision statements. Okay, you cannot use sort methods or anything else. You have to use decision statements to create the ascending sort for these 3 numbers. And then output them to the console in ascending order on separate lines. Here's the pseudocode to go ahead and sort these 3 integers. If integer 1 is greater than integer 2, swap the 2 values. Then, if integer 2 is greater than integer 3, swap those values. Then, if integer 1 is greater than integer 2, swap those values. If you do those 3 steps, the 3 integers will be sorted in ascending order. You will need to declare a hold variable to hold one of these integers while you swap the values. Kind of like what we did before when we flip-flopped the subtraction game. We have to place one value in a temporary hold area. Next to each integer, next to each integer will be even or odd, depending upon the value of the integer. Now, when you're doing this, it's complicated, okay? And I'm telling you, make sure you test every combination of random integers coming in. That can be small, medium, or large. And I just kind of broke out all the different combinations. You can have small, medium, large, small, large, medium, medium, small, large, medium, large, small, medium, and large, medium, small. And you should go and make sure that you test every one of those scenarios to make sure that your logic will eventually wind up sorting them in ascending order, 7, 8, and 9. I use these as examples. Finally, calculate the sum, the product, and the quotient, integer 1 divided by integer 2 divided by integer 3 of the 3 integers and put them to the console. Be sure to check all calculations and make sure that they are accurate. Here's a sample console output. Please enter an integer between 0 and 99. I didn't read my instructions and I put in -1. The program comes back out and says, outside the range, please enter an integer between 0 and 99. I put 100. I'm still not reading. That's my second strike. I'm out. And I'm using if statements. No loops, if statements. I made 2 mistakes. It says outside the range, program ending. That's where I issue my return statement. Now, here's where I go ahead and use the use correct entries. Please enter an integer between 0 and 99. I'm still not reading my instructions, and I put in -1. It says outside the range, please enter an integer between 0 and 99. I finally got it. I put in 80. That's between 0 and 99. It accepts it, and it says next, enter another integer between 0 and 99. Okay, I put in 20. What did I put in? No, I put in 100, and it didn't like it. So it said outside the range, please enter another between 0 and 99. Then I figured it out, and I said 20. All right, so now I have my range. It's 80 to 20. I want you to print out the range, but I want the range to be in ascending order. I don't want you to say the range begins at 80 and ends at 20. I want you to say the range begins at 20 and ends at 80. So for each of those numbers coming in, you're going to have to determine which one is bigger and which one is smaller, and then put the smaller one first and the larger one last in this output statement. Next, the three sorted random integers between 20 and 80 are, and now you're going to generate three using this this method right up here. You're going to go ahead and generate three random integers. In my case, I generated 20, maybe 48, 21, and 80 in that order. I need to sort those. And the way to sort them is to use that algorithm that I gave you up above. And now they're sorted, and I need to go ahead and put next to them whether they're odd or even. And the way you can do that is right after you put out the number, you could go ahead and do the modulus function, modulus 2 function, equal to 0. And if it's true, it's even. Otherwise, it's odd. So that's a little tip there. Then you go ahead and you take these three integers and you take the sum, add them together, multiply them together, and put out the product of 21, 48, and 80 is that large number. And the quotient is going to be integer 1 divided by integer 2 divided by integer 3. And I got this crazy fraction right here. Now you may be thinking, this is all integer division. Well, what you may want to do is declare a variable called quotient of the type double, and then do this calculation and have integer 1 times 1.0 divided by integer 2 times 1.0 divided by integer 3 times 1.0 in order to get precise division. Otherwise, we know with integer division, you're going to get very imprecise results. And I'm looking for precise results for my quotient. You must also
I have a
use
question, Professor.
Yep, go ahead.
Is it necessary to multiply all three by 1.0 rather than just the first one, the leftmost, since it becomes a double, and then when you divide by integer 2, it stays a double. Any subsequent divisions will stay a double.
Okay, well, test it, okay? Test it. I don't want to say yes and I don't want to say no, but it's my belief, because you don't necessarily know whether or not you're going to get a double. It's always safe to go ahead and do the 1.0, multiply times 1.0, and then you know you're dealing with a double.
Okay.
Okay?
Now, is it okay, so just to do one variable as opposed to the flow chart in which you have three different ones?
For integers?
For the quotient, yeah.
I think my solution, I used a few variables. I think I used quotient 1 is equal to int 1 times 1.0 divided by int 2 times 1.0.
Yes, and then you did quotient 2 and then quotient 3.
Right, right.
Yes, something like that.
I did it in steps. I try to keep it as simple to follow as possible. You can go ahead and rewrite people's code and make it the most, you'd be pulling your hair out trying to figure out what they're doing, unless they commented correctly. But I try to write my code such that the normal programmer coming in after me can go ahead and figure out what I'm doing. So that's what I did. I would create, you call them work variables. They're variables that never get put out, but they're used to go ahead and store data done by other calculations, and then you use those work variables to eventually feed a variable that you're going to print out.
Okay.
Okay?
Got it. Yep.
Okay. You must also use proper naming conventions for all variables. I want you to start using real good programming habits. As these assignments get more and more complicated, like the restaurant bill, you need to start making sure that your variable names are crisp and that you use the proper casing, the camel casing. So make sure you use proper naming conventions for all variables. Include a program header documentation block. Use block comments and line comments. Make your code look very good. Indent things properly. Space where you need to space. I'll leave it up to you. And zip your lab 3 folder and you know, you got the drill from here, right? Call it your name lab3.zip and send it to me as an attachment in Blackboard. I also gave you the flowchart for this, which should be very helpful. I'll make this larger. Going through this, let's see. We're getting input, and we're looking to see if it's less than 0 or greater than 99. If it's true, you're going to ask again, and if you get another bad one, you exit the loop. But if you get a good number between 0 and 99, you're going to go ahead and ask for another input, input 2. These are just variables names that I used in visual logic. And do the same thing. So this segment of flowchart is pretty much identical to this one here. We're going to go ahead and see whether or not the second integer that I got from the console is between 0 and 99. If it isn't, we're going to ask the question twice. If you don't answer it right, we're going to exit the loop. Otherwise, at this point right here, I now know I have a good range. The range I used was 80 and 20. Now you got to ask, is 80 less than 20? Is input 1 less than input 2? And if it is, you got to make sure that min, the variable min, has the smaller one in it, and max has the larger one in it. If it's false, you have to make sure that you assign the right inputs into the appropriate max and min. Then we have down here, we're doing that big calculation. Int 1 is equal to the min, that whole thing, random, whatever. And so now we're going to get 3 random integers between that narrowed range, 80 and 20. Int 1, int 2, and int 3. If int 1 is greater than int 2, we're going to flip-flop them. If int 2 is greater than int 3, we're going to flip-flop them. And here's the 3 steps to do. Create a temporary variable to store int 2, then move int 3 into int 2, and then take the temporary and put it back into int 3. And then the third step is if int 1 is greater than int 2, then flip-flop them again. The range begins at min and ends at max. So now we've calculated that all out, and now that gets put out. And the 3 sorted integers between min and max are, and if you follow my flow chart, it goes to over here. And we have where I do my modulus function, my modulus 2 function on int 1. If it's equal to 0, well, then it's even, and I put out even. For the second integer, I do a modulus 2. If it's even, it's even. And if the third integer, if it's even, I put out even. Otherwise, I'm putting out the integer is odd. And then the last piece is just doing the sum, the product. And here's where I did quotient 1, quotient 2, and this is like, I'll call it the master quotient, the overall quotient that's going to be put out. These are work variables, quotient 1 and quotient 2. So quotient now gets calculated. And then I put out the sum is this, the product is whatever the product is, and the quotient is that. So hopefully this flow chart will help you in tackling this problem. And I wouldn't suggest you sit down all at once and try and write this program. Do it in pieces. You may want to do this piece first, or these first few pieces, and then take a break, and then go ahead and tackle the next piece, and then the final piece. Okay, that's your lab 3. Does anybody have any questions?
I have one last question, Professor. This is Julio again.
Yes.
The naming of the project, you want us to give it a specific name. should the same be for the package and the main class?
Okay, here's what you need to do. When you go into NetBeans, you're going to go do new project. It's going to be a Java application, and up at the top, it's going to ask you for it'll pre-number something, Java application 20, 22, whatever the heck you're up to.
Yes.
Change that to be Lab 3, uppercase L, AB03. All right, and then just prompt your way all the way through, and then you'll finally get the package created with the right name. The package will be lowercase Lab 3. You write your code.
So you want to have the package and the main class the same name as the project.
Yes. And then when you go ahead and you get out of NetBeans, you stored it wherever you said you were when you were creating your Java application. You go to that place where you stored it, and that's a big folder. And what I'd like you to do is to zip that folder, right-click, and send to compressed zip file. And then that'll now be lab3.zip. And then do right-click, rename, and call it Julio lab3.zip. And then you attach that in Blackboard. Okay?
Okay. Yep. Thank you.
Okay. Any other questions? Okay, well, if that's all we got, then I'm going to call it a night. Thank you guys for participating, and we will talk again soon. Good night now.
Good night.